Welcome back to You Can't Spell Functions Without Fun. Welcome back to You Can't Spell Functions Without Fun, Part 3. So, just as a check-in, what we last looked at was a function that could return values, okay? So a function is a group of lines that has a name and that's not evaluated until it is called. Remember, these lines, they don't do anything until we actually call the function. And we call those functions, it's also called invoking functions, using the function name in the parentheses. That's what we've got right here with the parentheses. And in some cases, a function returns a value, and we can take that and store it into a variable. So let's take a look at what this one does. Python gets to this line, def, and it says, I'm going to create a function. So it takes these 4 lines of code and stores them into this variable, this function name, get and add 2 numbers that has the parentheses and the colon. And then it gets, there's no line here for it to do, so it gets to this one, and we're at an assignment operator. So it first looks to the stuff on the right-hand side. It says, what's going on here? Get and add 2 numbers is a variable that holds a function. I put the parentheses on it, and that's like, time to call the function. And when that happens, Python goes back up to where the first line of that function and starts running these. So it gets the input of the first number, converts it to a float, and float is a function that returns a value, and we store that using the assignment operator. We assign this value to that variable. Over here on the right-hand side for this next line, there's another assignment operator. So we do input this right here inside the parentheses. That we look at that. What does input do? It returns a string. So it returns a string here that float then uses, and then float returns a value of a decimal number, and the assignment operator assigns that to that variable. Then we get to the next one, and there's another assignment operator. That's just adding 2 things together, so that adds those 2 together, and then whatever the result of this addition operation is, that gets assigned to total, the variable, and then we return whatever is inside that variable. So that comes back down here. Once it's done, it comes back down here, and it's like, I've got a return value. And this return value is what ends up getting assigned to a variable. It's like this function gets replaced with whatever number ends up being the sum of those 2 things. It's like it gets replaced and then gets put inside there. So this is how functions that return values work. So let's think about a use case, a reason for having functions. So in this case, let's consider this code. We're asking for a player's name, and while that name is empty, we say, please don't be that way. Come on, give me a name. We assign it back to player 1, and it keeps checking that it's empty. And once it's not empty, once we actually type something inside there, the while loop is false, and it jumps over all of its stuff, and then it goes to player 2. And player 2 variable here, we ask, what is your name? And you can see this line here and this line here exactly the same. And then what we're doing is we're checking, is the value I just entered equal to empty string? Is the value I just entered into equal string? And if it is equal string, then we say, please don't be that way. And then we get another name and we assign it to a variable. And we get another name and we assign it to a variable. So these 2 blocks of code do the same thing. The only difference is where we are storing the output of it. In this one, we want to say player 1, and in this one, we want to say player 2. So we can use functions to help simplify this code. And what simplify means is different than what you may think it means. It won't necessarily reduce the number of lines, but it will reduce the number of times we do the same thing. So here's that code again. It gets 2 players' names, making sure the names are not empty, okay? And so this block of code and this block of code do the same thing. They get a name. They make sure the name is not empty. They print, come on, please don't be that way, if it is empty, and then asks for the name again, and it does it twice. The only difference between these two blocks of code is where we're storing that value when we're checking the name. So in this first one here, we're doing player 1, and in this one here, we're doing player 2. But the logic, what it's doing is the same each time, which is getting a name and making sure the name is not empty. So we can do that. We can write a function over here called getName. And its only job is to get a valid name. Here we have input, what is your name? And that's what we have over here. What is your name? And we store that just into a normal variable name, because all we're doing, it's just a name. We don't know whose name it is. We just know it's a name inside this function. And then while that name is empty, please don't be that way. Give me another name, stores it in the name. We check it again. Once it's a valid name, we return that value. And so that's the value that comes out of the function. So down here, we have player 1 is equal to getName. And so this getName, remember, it's a function name and the parentheses. It's going to come up here and invoke this function. It's going to get a valid name after looping however many times because somebody just keeps hitting enter. And once we get a valid name, that's the name that gets returned. And so that's the value that gets end up assigned to player 1. And then the same thing here too with getName. Then it comes up here. Look at that. We're calling a function twice, one right after the other. And it runs this code again, waiting for somebody to get a real name in here. And then once we have a real name, it comes over here. One of the things I want to point out is when I call getName this time here, and it comes up here, this is a brand new variable for getName. Once we return, this all goes away. It's like it never happened. That name variable goes away. And then the second time I call it, right here, name is a brand new variable again for this call. So it's not like the old name just hangs around. These local variables, and we're going to really investigate variables. So in the next sections, these variables are brand new every time we call this function. Okay, so far, we've got functions that don't return a value. They return none. And they just look like a function, def, some function name, parentheses, colon, and then some lines of code, but no return keyword. And then we have functions that do return a value, def, get the name of the function, right here, the parentheses, the colon, lines of code, and then a return statement. It says return this value from the function. What we haven't seen yet is something like this. Here, the input function, we give it a value. How old are you? We give it that string, and it prints it out for us. How old are you? And then we type in 13, and when we hit enter, that string as a 13, it gets sent back. That's the return value for input. And then it gets assigned because of the assignment operator into age. And then we take that string 13 here, stored inside age, and we give it to the integer function. And the integer function takes that value and turns it into the number 13. And then down here with print, we give it more than one value. And so in this case, we give it next year you'll be, and this, whatever value this is, that gets printed out. So this ends up printing blah, 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 and this ends up printing this here, blah, blah, blah. So we're giving values to functions for the functions to do something with them. When we give a value to a function like this, it is called an argument. Doesn't that seem weird? It's an argument. I have looked into the history of why it's called an argument, and I can't really find a very good answer other than it has something to do with math and the translation from Arabic, because algebra comes from the Arabic mathematician, or the Middle Eastern mathematicians who spoke Arabic. Originally, it's al-Jabbar. And so that's the name. And this idea of what we pass to a function in algebra, they named it argument in the ancient Arabic language, or not. It's not that ancient, right? I mean, it's like Middle Ages time. But anyway, so these are called arguments. When we give a value to a function, it is called an argument. Okay? So our functions can also take values. Here we can pass in two different values. It's just a comma separated list. And these values here become variables. These are variables for the function to use. These things are called parameters. These here are parameters. Good prompt is a parameter. Bad prompt is a parameter. Those are the names of the variables for this function. And then we can continue to declare our own variables. Here we're declaring a variable named value. And so what getString does, getString is a generic way of getting a valid string. So here we're going to call getString with one argument, your name, and another argument, I need your name. What happens is Python takes this value right here, your name, and it assigns it to this variable, good prompt. And then Python takes this next argument and assigns it to this parameter, that variable, bad prompt. So when getString is called with these two values inside getString, good prompt is now your name and bad prompt is I need your name. So it says input, give me that prompt. So it's going to print out whatever is inside good prompt. So it's going to say input your name, and then we type something in, and then that gets sent back to value. If it's empty, this code will do another input, but it will use the bad prompt, and it will say, I need your name, because that's the value that was stored in bad prompt when we called getString here. So it'll print that out, and it'll loop back up here and check again. And if it's still not a good value, it'll come back down here and print it out again. I need your name. And then eventually this will end up returning the string. So here's another example. It's a little more complicated. So let's take a look and see what it does. So we get to this line and Python says, okay, this is going to be a function definition. The name is print numbers, and it has two parameters, two variables that you need to give it to be able to run. One is called nums, which is probably a list of numbers, and one is called prefix. Now let's take a look at the lines of the code. Inside here, it loops over each of the entries inside numbers, and we get another variable here, which is each value num, and then it prints whatever was in the prefix here with the number after it. This is kind of weird. So let's take a really concrete example of this. Here I'm calling print numbers, and the three numbers are 2, 4, 8, and the prefix is number. So these arguments get assigned to these variables way up here like this. And so now nums is the list 2, 4, 8, and the prefix is the string number, like that, colon. So now we get to this for loop. For num and nums. Nums is 2, 4, 8. So it's the values 2, 4, and 8. So the for loop says, what's the first value in that list? So it's 2, and that's the value for num. It goes into its for loop, and it prints prefix. What was prefix? That's the value, the string here, number, which came from the second argument we passed in, number. So we print prefix, and that prints out this part right here. And then we print num. And what's the value of num on the first loop? It's that first entry, 2. And then, just like we've seen before, like in the review, the next time it loops, it'll take the number 4 and put it inside num. And then it prints the prefix, number, and then the next value that's in num, 4. And then it comes back up here, and it's like, here's that next value, 8. We'll assign that to num. And that it prints out the prefix, number, and then the num, 8. And then it gets up here, and it's like, what's the next value? Nothing. So the for loop is done, and it comes down here. It jumps to the next line. There is no next line. And so the function returns here, okay? It returns back out of print numbers. So this is a more complex example of doing something with two arguments, a list and a string. And we're using that in two different places here. That's where we're using it. This nums here is the list the for loop uses. This prefix here is the value that's printed first. And then each entry inside num, that's used in the second argument to print. And so it prints out number 2, number 4, number 8, because this number, and then 2, 4, and 8. Okay, so now we're going to talk about specific labels for variables. I don't like labels, man, but hey, we're going to talk about labels here. If you just have a Python program and it's got variables that aren't part of a function, if they're just hanging out here, name and age, these are known as global variables. And you can use global variables anywhere in your code. And I'm going to say it right now. Global variables are bad. I'm going to keep saying it as we go through here. When you have variables for a function, those are called local variables. And the variables here are A, the parameter A, which is going to get a value because you have to give it when you call sum. The variable B, the parameter B, and then inside here we declare another variable total. So the only way to call sum like this, sum, is to give it two numbers, 3 and 5, and then 3 becomes the value for the variable A, 5 becomes the value for the variable B. We just have a special name for these variables. Those variables are known as parameter variables. And then inside here, this is a variable local to the sum function. It's only inside sum. Once we return this total out of sum, all of this code, the values inside the code get erased. All of the values go away. And we're going to see how that works in something called the call stack here in a couple of minutes. Did I just say call stack? What am I, from Queens? Okay, so global variables are confusing. That's what makes them bad. So here we have a global variable named nor, okay? This function, print global name, when it says print name, Python looks and says, is there a local variable named name? Nope. Is there a parameter named name? Nope. So you must mean the global variable. So it comes up here and looks at the global variable name and then prints out nor. That's what ends up getting printed out. Here we have print local name. When it gets to here, it creates name and sets it to ASA. And when it gets to this print, Python says, is there a local variable? And the answer is yes. So it ends up printing this name. And then down here where it says print param name, we have a parameter named name. And when it gets to this line, print name, Python says, is there a local variable? Nope. How about a parameter? Yep. Great. That's what I'm going to print. What about this name up here? Here I set name is equal to ASA. Why does it not change this name? Global variables are confusing. Let's never use them ever. Okay. That was my little ranty rant box there. And the reason that this doesn't change this is because when we create this, that automatically becomes a local variable. And to be able to change the global variable, we have to tell Python, hey, we want to change the global variable. And we can do that by saying inside our function, we want to use the global variable name. When this one right here runs, does not change global, this is a local variable. So even though this one is called name and this one is called name, inside this function, whenever you say name, whenever you use the variable name, it's going to look at the local variable. Over here, because we say we want to use the global name, now whenever we use this variable name, it's this variable. How confusing! That's why this is bad. Let's not use global variables. So how can we not ever use global variables? By using a global variable. But this is a special global variable. This is dunder name, double underscore name, underscore underscore name, underscore underscore. It is a built-in variable to Python, so we don't have to manage it. Python takes care of it for us. And what we do is our program right here, we put it inside a function. I've named it main, but you can name it banana, def banana. And then at the end of our Python program, we check if name, dunder name, is equal to dunder main. If this is true, then we are running our program directly. And then we tell it to call our main function. And then it's going to come up here and call our main function, just like we've seen with functions. And now all of these variables are local to that main function. So it's not like we're going to have any confusion whatsoever. So this is a nice way, and this is the way we should do all of our programs from now on, is we should use this check here to run our banana program or our main program. It's called main here because I'm a professional professor, but you're a student, so you can name it banana, def kumquat. Okay, so now we have if name is equal to main, run main. And the main function is right here. And so when main runs, it says player one, get name player one. And this is the prompt it's using. And then up here we have get name prompt. So it's passing this prompt into here. See, we are inside a function main and we are calling another function get name. Okay? So we come up here to prompt and we have a local variable name. We have a local variable prompt. We prompt the person with player one. It gets assigned a name. It checks to make sure it's good. Then it returns that name. So we have a name inside player one. We do the same thing for player two. We get a value for player two. And then it prints out the two local variables, player one versus player two. So let's take a look at the call stack, which is how Python manages our memory. How does it manage all of these local variables here? How does it do all of that? Luckily, our Python debugger can help us figure that out. So here we are inside a program that is the code we just saw. Get the name, here's our main function, here's that check to run our main function if it's good, okay? That means player one is going to be a local variable domain. Player two is going to be a local variable domain. Get name is going to have a variable named prompt and name. And whenever we execute a function, whenever we invoke it, call it, once it starts running, Python is going to create these local variables for us as it runs. And every time we call a function, it gets brand new values for those variables. Okay? So let's take a look and see how this runs. I'm going to go ahead and run this in my Python debugger. Here's our variables and here's the call stack. Okay? Right now we're in a call stack called module, which is what Python uses to run our program. It's this thing called module. So here we are in get name. If I step into it, it doesn't go inside. Remember, these lines of code here don't get executed. They get stored inside the function name as a variable, okay? So now all of these lines of code are stored inside that variable. And if I look over here in my global variables, my functions, you can see there's now a get name, which is a function. I'm going to close locals just for now because we don't have any local variables. I'm going to try to step into this again and it skips over. And you can see now here we've got two global function variables, one named get name and one named main. And both of them have functions stored inside them. And if I can make this smaller, you can see they're at different memory addresses. They're in two different places in memory. This variable get name is at blah, blah, blah 3EC0. And this one is at blah, blah, blah 0220. So you can see they each have their own place in memory. And that's where that code is stored. Okay, so now I'm going to step into the if statement. So here we are at main. If I look in special variables and scroll down, you can see that name is equal to main. That's the value. And you can see there are a whole bunch of other dunder, double underscore variables in here. We're just looking at name. It's equal to main right now. So this if statement is going to be true. So I'm going to step into it, and now we're at main. So now what I'm going to do is I'm going to step into main, and now I'm inside the main function. Here's what's interesting. In our call stack, we now have a brand new area for variables. This is where we were. We were running inside module, but once we come inside the main function, a new entry in our call stack gets created. And this area right here gets its own variables. So what I'm going to do is I'm going to show you that. I'm going to go one more. What's going to run right now? Because we have an assignment operator here, because we have this assignment operator, it's going to look at the right-hand side, and that's another function call. So that's going to jump us into the next function. So if I step into this, now we're up here. And you can see we started out in module, we called main, we got inside main, that got added to our call stack, and now we're up here to get name, and we're inside that part of the call stack. And if we look at our local variables, you can see right here, we passed in player 1, and that's the value that got assigned to this parameter, which is a variable for the function, and that's what prompt is, okay? So prompt lives inside this stack, this area inside the memory, just for get name. If I come down here and I look at main, you can see it has no local variables. Where's this prompt thing? Prompt is a variable for get name, not a variable for main. So main can't even see the variable name prompt. I'm going to close globals. It can't even see that. There is no variable name prompt because it's up here in get name. Prompt is just for get name. So now that we have that, I'm going to take a step. Oh, and I have to actually enter the thing over here. Okay, so input prompt. That's what's running right now. I'll make it Curtis. Enter. And now we're back over here. And now you can see here in get name, we have 2 local variables. The prompt we passed in as a parameter variable, and we declared a variable, a local variable named Curtis that came back from this prompt. Now that we've got that, let's look at the main. There's no local variables there named name and prompt because we're down here. Look at the variables in this block of code. There's nothing named name. There's nothing named prompt. But when we're inside get name, we definitely have these 2 variables, the prompt variable and the name variable. So Python keeps these in different areas inside our memory here. So right now, get name has name and prompt, okay? So I entered Curtis. The while loop is going to get skipped. Now we're going to return the name, and the name is Curtis. We're going to return that. Now it comes back here. And there is a special kind of variable called a return variable for get name, which is equal to Curtis. That's what this whole thing now equals. It equals Curtis. And so this is Curtis, and it's going to get assigned to player 1. So when I take a step, now you can see player 1 is Curtis. Also, when we returned from the function, look down here in the call stack. Get name has gone away. We exited the function. We left we ran out of lines to do. So once we came back down here, all of the memory that get name was using, the prompt variable and the name variable, all of those get erased by Python. They're gone. Look at that. They're gone. So now we're here at player 2, and we can step into get name again, and now it shows back up. And now the prompt variable gets created again, and it's got player 2 in it because that's the value that we passed into prompt. So now we're inside here, input prompt. It's going to want to run that. So I'm going to get prompted over here. Curtis versus Timothy. Timothy is my brother's name. Hit enter. So now look over here. The name is Timothy. That value I typed in, input returned it, and the assignment operator assigned it to this variable. The if statement, or the while statement, which is like an if statement, but it keeps running, as you know. The while statement, this is false. Name equals empty is false. So it'll skip over that. And now we're at return name. Again, watch what happens the next time I step. Get name is going to get erased from the call stack, and all of these values, the name variable and the prompt variable, these things here will get erased from memory. And so this return value here is the only thing that I can get in main. So when I step here, you can see we're now on main, and the return value for get name is Timothy, which is the value I typed in, was put in name, and that was the value that was returned. But get name is gone from the stack. So it's like name and prompt never existed. It gets erased from memory automatically for us. So now I take another step, and that return value from that most recent call gets assigned to player 2 right here. And then we print out those values, Curtis versus Timothy. And now that we're at the end of this function, we come down here to where main ended. And you can see main is now gone from the call stack. Player 1 and player 2, those variables no longer exist, and we're back in the module. And the module has a special variable, the return value of main, which is none. And then that ends our program. Thank you. So that's how the call stack manages local variables. Every time we go into a function, Python creates a new thing on the call stack. So we start out in what was called module, which is just like, that's where global variables lived. Once we entered main, it created a new stack here. It created a new place for main. And all of the variables for main, player 1, player 2, the return values, they all get created inside this block of memory that only main can see. And then when we call get name, and this comes up here, it adds another entry onto our stack. So here's get name, and we pass in the prompt, which is a variable. So prompt automatically is whatever we tell it, player 1 in this case, player 1, like that. And then when we call input and type something in, we get a name, which is like Curtis. Then we return that name, okay? What happens at that point is pretty complex, but really nice. Down here in main, we get the return value of get name, and that value is equal to Curtis. So what it does is it takes that value Curtis, and Python, not our code, Python can see all of this. Python takes Curtis and copies it into this special variable, and then it totally erases the original memory, that original stack there. So there's no more get name once we return. And then that value, this return value, is assigned into player 1. So it gets its own variable, player 1, like that. And its value is Curtis because we assigned that in there. Then we get to this get name, and Python adds another value back onto the stack, another frame. That's what they're called. Get value like this. And inside here is where all of the local variables for get value is. Prompt is going to be player 2, like this. At this point, get value has a variable named prompt. Main can't see that because it's up here inside the get value frame. It's inside that part of the stack. And then we end up getting a name, and that ends up being Timothy. Hello, Timothy. And then once we get to the end and we return that name, this value that gets returned here, that gets put into this special function, that special variable as well. So it's not Curtis anymore. It's now Timothy, like this. It's now Timothy. So now this return get name variable, this special variable, has the value Timothy, and that gets assigned to player 2. And so now we have another variable in here that Python has created named Timothy, like this. And once this got returned here, Python went and erased all of this old stack here. It erased all of this stuff for that call for get name. So now we're only inside main, and we print out player 1, which is a variable inside main, versus player 2, which is a variable inside main. And then once we're done here, we come back here to the module level, and Python's like, well, you must be done with main because you've exited it. So now all of those values and variables go away. So what variables and values do we have here? None. We don't have any because in module, they're only global variables and values. And again, so that's how Python and a lot of programming languages, they have a thing called a call stack. Every time we enter a new function, Python adds a new entry onto the call stack for that function, and that's where all of its local variables and values are stored. So we've definitely seen a lot during this 3-part presentation. We reviewed everything that we knew up until now. We learned that functions are blocks of code with the name. The blocks of code get stored in the name, and they don't run until you call them. They just hang out. Functions have parameters, which are local variables that you can assign, that you pass into it, and they have return values. Sometimes both of these are optional. That's why they can have them. They're not required. Functions can also just declare local variables to use, and functions can call other functions. With respect to variables, global variables are bad and can cause bugs in your program. And we can use the dunder name variable to do if underscore underscore name underscore underscore is equal to 2 equals underscore underscore main underscore underscore colon, and then we call our function, the function we want it to run, banana. And that's it. That's functions in Python.